Okay, well, I'm super excited today because I get to introduce another number system to you. They're called imaginary numbers. Um, so when we take a look at, we're going to look at some imaginary numbers. All right, then we're going to look at a different number system again next section. First of all, we did not do section 6.6, which talked about rational numbers as decimals, either terminating or repeating decimals. So, because I'm confident you guys can use a calculator to come up with a decimal of a number. So we're going to take a look at imaginary numbers. So for visually, let me kind of show you what's going on. In elementary school, okay, you learned all the way up through Algebra 1 and up until now, we've learned about this number system called real numbers. And we started off with whole numbers in kindergarten and first and second grade. You learned how to add them. You learned how to subtract them. Third and fourth grade, you learned how to multiply and divide them. You learned that real numbers could also be fractions and decimals. So that took you through fourth and fifth grade. Then we looked at square roots, which took you through fifth and sixth grade. Positive and negatives, that took you through sixth and seventh grade. So we've done a lot with real numbers. That's one type of number system, graphing them and all those operations we aforementioned, and powers. Now we have a different number system. This number system, first of all, the real numbers, remember, were the rationals and the irrationals. You have that again, first day of school, so I'm not going over that all again. We have a different number system called the imaginary numbers. All right? And the imaginary numbers, we use an italics I. So try not to use a straight I. Try to make it like a little italics. Okay, kind of like a number 2 with a dot over it. And here we go. I'm going to give you the definition of an imaginary number. The imaginary number, the definition of I is the square root of -1. So in the past, anytime you had the square root, not the cubed root, but the square root of a negative, we always said no real solution. And that's correct, because the numbers are not real, they're called imaginary. So here are the two things we need to remember. I is exactly the same as the square root of -1. Now, if I square the left side, I get I squared. If I square the right side, as we did earlier in the chapter, it undoes the square root, and so I squared is -1. So that's what you need to remember right there. There's the definition of an imaginary number, and we're finished. So now what we're going to practice is how to add, subtract, multiply, divide. But before we do that, we need to first start in the same order we've done before with simplifying imaginary numbers. And then I also want to talk to you about the powers of I, which I think I'll wait until a little bit later in this lesson. So here we go. So let's start with these operations. Let us begin by simplifying. Okay? Let's say I ask you for the square root of -7. Well, up until today, prior to today, you would have said no real solution. And I would have said, you're absolutely correct. There is no real solution, but we are going to end up with an imaginary solution. So I'm going to work this one out the first time. This is exactly the same as the square root of -1 times 7, which means this is the same as the square root of -1 times the square root of 7. Well, we just learned the definition of the square root of -1. By definition, the square root of -1 is the imaginary number I. So the square root of negative 1 is the pure imaginary number. So this gives me an I. I cannot simplify the square root of 7, so we're finished. And that's our answer. I, make sure it looks like an I, make sure it does not look like a 2, make sure I can tell that it's an italics I. And that's it. All right, let's say I asked you for the square root of negative 9. Well, I'm going to write it out again. When in doubt, write it out. This is the same as negative 1 times 9. Square root of negative 1, square root of 9. The square root of negative 1 is I. The square root of 9 is 3. Since I is still a variable, I represents the square root of negative 1. I want to put the 3 first. So I'm going to put it as 3I. So you might be asking yourself right now, well, wait a minute. If the number has to come first, how come on the first example we didn't put the square root of 7 before the I? That's a great question. Now you can, but you need to be careful. And let me show you what I mean by that. The reason it's pretty common to put the I first is, I want you to be careful. Technically, we've always said put the number as the coefficient. Well, if you write too quickly, it might look as though the I is under the square root sign. So therefore, universally, meaning across the entire globe, universally, to make sure that the I doesn't look like it's under the radical sign, it's become better to write it as the I is clearly on the outside and then the root 7. Okay? So be careful. I do not recommend you put the square root of 7 first because as you notice, you're not sure whether this is inside or outside the radical. So therefore, it's common practice to put the I in front. However, if they both come out, then you can go ahead and put the I as the variable. Okay? All right. Now, we do want to make sure of a couple things. Let's see, what do I want to do next? Let's do this one. I kind of did that. Okay, let's do square root of negative 12. Okay? So if I'm working this out, a couple things. Some people will automatically, as soon as they see the square root, not the cubed root, not the fourth root, not the fifth root, the definition is the square root of negative 1. As soon as you see the square root of a negative, you could take the I out right away. But when in doubt, you could always write this as a negative 1 times a 4 times a 3. Look for perfect squares. And now you might see that the 4 is going to come out, the I is going to come out. So you have 2I and the square root of 3 left over. Now let's take a look at some adding, some subtracting, some multiplying. All right. Well, if we are adding, for example, let's say I have you add maybe something like 5 square roots of negative 6 minus the square root of negative 24. Well, don't change the concept. Whenever you add or subtract, you combine like terms. In order for them to be alike, these radicands have to be the same. Well, they are clearly not the same right now. So simplify each term like we just did. If I take out what I can quote, take an I out, take an I out, take a 2 out. So I end up with 5I square root of 6. So now my radicand is the square root of 6. That's what I'm looking for like terms. I can take out the 2, I can take out the I, and notice again, I have the square root of 6. So technically I have 5 I root 6s minus 2 I root 6s. So I have similar terms of I root 6. So this will simplify to 3I root 6. Okay, because I could have factored out the I root 6 and I would have been left with the 5 minus 2. All right, let's take a look at, we've simplified, we've subtracted, which is the same as adding. Here, let's try multiplication. Let's say we take a look at the square root of negative 5 times the square root of negative 75. Well, the concept we did earlier in the chapter. We're multiplying. Since we're multiplying, they don't have to be alike. Since we're multiplying, this is one term. These are just factors because those are the parts of the multiplication. So, sorry. So I can, here I'll write it out. This is negative 1 times 5. This is negative 1 times 25 times 3, because I was looking for perfect squares. I have some perfect squares. I can take an I out. I can take an I, and I can take a 5. So now, just like we did before, multiply the coefficients together, multiply the radicands together. That gives me a 5I times I, and a 5 times 3 on the inside. 5I squared, root 15. But if you remember how we started class, imaginary numbers, I is square root of negative 1. I squared is negative 1. So we are left with negative 5 root 15. So remember, I is the same as the square root of negative 1. I squared is the same as negative 1. Those are identities. Those are facts. Those are facts. Okay? All right. Now, let's practice a couple of things. I know I've only done one adding or subtracting, one multiplication. There are some more in the book if you would like some more practice. Okay? Here, let's try, I'm going to try another multiplication. Let's say I asked you, I don't want the black, let's do the blue. Or it's still damp here. Simplify. Trying to find some, here's number 10. It says 5I times 3I. Well, again, it's multiplication, so it's commutative and it's associative. So I could commute them and put the 5 times 3 next to each other, and then the I times I next to each other. 5 times 3 is 15. I times I is I squared. But we know anytime you see I squared, you can replace it with -1. Okay? Let's say I look at number 16. Number 16 says, take the quantity 8i and square it. When in doubt, write this out as 8i times 8i. 8 times 8 is 64. I times I is I squared. But anytime you see an I squared, replace it with -1. So we're left with -64. Okay. We can move along. This is number 20. We're still multiplying. I'm just going to make it look different. What if I gave you 3i root 5 quantity squared? Oops, almost off the screen. I apologize. Well, it's still multiplication, and when in doubt, just expand it. Write it out. All right, 3i root 5 times 3i root 5. It's multiplication, and multiplication's commutative, so move them around. I'm going to choose to put the 3 times 3 together. I'm going to choose to put the I times I together. And I'm going to choose to put the root 5 times root 5 together. So I can commute them and associate them, and I am left with 9 I squared times 5. 9 times 5 is 45. I squared is -1. So I'm left with -45. Okay, so slow down. Take your time, write it out. Okay, so we've looked at adding, we've looked at simplifying, we've looked at multiplying. All right, let's take a look at division. This is number 24. You actually already know what to do. Let's just think about what we need to do. It says 8 divided by 3i. Well, we have a problem. We have an I in the denominator. Why is that a problem? Well, let's think about it. We know what I is. I is a square root. Are we ever allowed to have a square root in a denominator? Well, the answer is no. Remember, this is the same as saying the square root of -1, so we're not allowed to have a square root in the denominator. But if I can turn it into an I squared, then I can replace it with the number -1. So I need to rationalize this. I need to turn the denominator from having an I into having an I squared. That way, if I have an I squared, I can replace it with -1. So I'm going to use the technique that we've done a lot, and I'm simply going to multiply by 1. I'm just making it look like I over I. And now, in the numerator, I have an 8i. In the denominator, I now have 3i squared. But we know that I squared is the same as -1. And so we now have 8i over -3. And it's better to write this as a negative fraction. A positive divided by a negative yields a negative number. So it's better to write it as a -8i over 3. So if I have an I in the denominator, we need to rationalize. So let's do number 28 to practice that again. 28 says the square root of 28 over 4I root 7. And there's a lot of ways you could do this problem. What I happen to notice is 28 is under a square root, 7 is under a square root. So I'm going to rewrite this as, how do I want to rewrite this? I'm going to rewrite it, I want to do it this way, and I'm going to put, I don't want to do it that way. I'm going to put the square root of 28 and the square root of 7 together. So yeah, I will do it that way. Divided by 7 is 4. Square root of 4 is 2. So I now get 2 over 4I. Well, the 2 and the 4 reduce. So I get 1 over 2I. Well, I'm done, but I'm not finished. I now have an I in the denominator. So I need to make that into not having a square root in the denominator. I need to make it an I squared. And so now this leaves me with I over 2I squared. I squared is the same as negative 1. So I'm left with a negative I over 2. All right, and now got the same idea. Now you can see where, if we were to go back, and we'll be solving again, but now in algebra, when we solved some quadratics, powers of 2, degrees of 2, sometimes we said no real solutions. So let me show you how we could solve now with some imaginaries. Here's number 32. Solve y squared plus 400 equals 0. Well, back in chapter 4, if we had the difference of perfect squares, if this had been y squared minus 400, we would have had conjugates, y plus 20, y minus 20. But whenever we had the sum of squares, we always said it was prime. There were no real factors. That's absolutely true. There weren't any real factors because they ended up being imaginary. So I'm going to solve this like we did with a little while ago. What am I solving for? Y. How many terms have a y in them? 1. Isolate that variable term. Okay. Now because it's a y squared, I simply take the square root to solve it. When you take the square root, you need to take the positive and the negative root because you're putting the radical sign in the problem. And now technically, this becomes a negative 1. 400 is 20 times 20. So take out everything you can. I have a positive and negative. I can take out an I, and I can take out a 20. So I get 2 solutions, which we are guaranteed to have because the degree was 2. And those 2 solutions are both pure imaginary numbers, positive 20i and negative 20i. So we still got our 2 solutions. Okay. Let's look at 36. 4, I'm going to change the variable. 4x squared plus 39 equals 7. All right, we know how to solve this. We're guaranteed 2 solutions because the degree is a 2. We only have one term that has a variable in it, so let's isolate that variable term by subtracting 39. 7 minus 39 is negative 32. Isolate x squared by dividing both sides by 4. Now to solve for x squared, we simply take a square root, and since you took the square root, you get both the positive and the negative answers. Square root of negative 8, that's a negative 1. A 4 times 2. I'm looking for perfect squares or things that I can take out. And I can take out an I and a 2. But I'm left with a 2 still in the radicand. So there are my two solutions. Those pure imaginary answers of positive 2I root 2 and negative 2I root 2. All right, and then the rest of everything in here is adding and subtracting. So it looks pretty good. So we looked at I. But I did talk to you about, I want to show you a little extension. I want to show you something that the book doesn't talk about right here, but I want to go over the powers of I with you. The powers of I. Because I want to teach you something called a module, okay? Powers of I. So let's start with what we know. We know, let's start with what you know, and then I'm going to have you put your pencil down and just watch for a minute. The powers of I. We know that I is the same as I. So I to the first is the same as I to the first. Okay? And we know that I squared is the same as negative 1. Now, let's keep going, because we can use what we already know about exponents to keep going. So this is an extra piece of information. This is an extension on what is in the book for the GATE students. So let's just think about this. Let's think about, how do you get I to the third? Well, you get I to the third by multiplying I to the first times I to the second, because whenever we multiply, when the bases are the same, you add exponents. Well, we know I is I, and we know I squared is negative 1, so this is now negative I. How do we get I to the fourth? Well, you could say I times I to the third, or you could say I to the second times I to the second. Won't matter, you'll get the same thing. Let's say we go I squared times I squared. Well, I squared is negative 1. How do you get I to the fifth? Well, you get the idea. You could either take I to the first times I to the fourth, or you could take I squared times I to the third. I'm going to go I to the first times I to the fourth. That gives me I times 1, which gives me I. Well, how do we get I to the sixth? You got the idea. Okay? I'm going to choose I squared times I to the fourth, which gives me negative 1 times 1, which gives me negative 1. Well, I guarantee you the next answer is going to be negative I, and then the one after that is going to be 1. Okay? What ends up happening is I to the first equals I to the second is negative 1. I to the third, we found, is negative I to the fourth is 1. And then the cycle repeats itself. I to the fifth was I to the sixth was negative 1. I to the seventh would be negative I to the 8th would be 1. I to the 9, 10, 11, I to the 12. 13, 14, 15, 16. So this is what's called the base 4. These numbers repeat every time you get a multiple of 4. So the powers of I, you only need to know those 4 base numbers to come up with the powers of I. So for example, if I asked you to find I to the 17th power, okay, that's a 17. Here's what you could do. You could start counting. I to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8, 9, 10, 11, 12, 13, 14, 15, 16. I to the 17th, I. Let's do it again. Let's find I to the 20, I to the 23rd power. We're going to count it and then I'll show you a shortcut. I to the 23rd. Well, I can just follow this cycle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I to the 23rd is the same as I to the 3rd, negative I. So some of you may have already figured it out. Try this one. Find I to the 82nd power. Well, of course, you could start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But since this is mod 4, notice these are always in multiples of 4. So you could say, well, how many 4s go into 82? It goes into this 20 times, right? So that means I'm going to count through this cycle 20 times. And eventually I'm going to get I to the 80th, because 4 goes into 80 evenly 20 times. And the remainder is 2, because I'm going to 82. This would be 81, 82. So it's not so much how many times it goes in evenly. It has everything to do with that remainder that was left over. Okay? So it's pretty cool. This is what's called mod 4. This is a different base 4. We have all kinds of different bases that we go through. If you're curious about other bases or you want examples, just so I can show you use them regularly, ask me in class. Make a note to ask me in class for examples of other bases that you already are familiar with. Just because mathematics is very cool, not everything is base 10 like what we've grown up with. So this happens to be a base 4 system. All right? So that was a little bit extra. Who knows? You might see that show up somewhere. All right, you guys. So that's what we talked about with imaginaries. Your entire life, up until now, you have always dealt with one number system, kind of like a planet, Earth. One number system, real. There are other number systems out there, just like there are other planets out there. This number system is similar to ours in that we can add, subtract, multiply, divide, graph, powers, roots, all that. But it has its own unique properties. There's the definition. All right, so go ahead and get started on your imaginaries. And then next time I'll show you another number system. So until next time, have a great afternoon.